Okay, let's talk about simplifying exponent expressions. So we'll have expressions with terms with exponents in them. Okay, before we do that, let's talk about the exponent properties. So remember, we multiply like bases, we add the exponents. Divide like bases, you subtract the exponents, or it's numerator exponent minus denominator. We're going to play around with that one a little bit. Base to a 0, that's 1. A negative power is just 1 over a to that power, so it's a reciprocal. All right, so negative powers are reciprocals. And then powers raised to powers, you just multiply the powers. All right? Okay. Let's try something like this. So here I have 2x squared times y cubed. Notice this is all multiplication. So what does this mean? It's this 2x squared y cubed. It means I have that 2x squared y 3 times. And since it's all multiplication, I can simply just pick out the pieces that are like terms. So 2 times 2 times 2 are like, x squared times x squared times x squared are like, and y. Right? And again, I can do this because it's all multiplication. So this is really just 2 times 2 times 2, 2 cubed, x squared cubed, and y cubed. So it's really just like distributing this power to each piece, right? So if I do that, so once I realize it's all multiplication on the inside, I can just distribute this power to each piece and skip all this, right? I don't have to show these steps because I realize that when you raise multiplication to a power, that power applies to each piece, okay? Now be careful when we do this. This only works if there's a multiplication. So as soon as you see a plus sign, I can't distribute this 3 to both pieces because there's a plus sign. It's not multiplication, right? So look at this. I have 2x squared plus y times itself 3 times. And if I were to do just one of these multiplications, right, you'll get first, and then you'll do the 2x squared times the y times the 2x squared, and the y times the y. So just that piece right there, it turns into this wildly complicated, right, more complex expression. And then it's this times that. So I'd have to multiply each one of these pieces by this. So this is clearly not 2x cubed or squared cube plus y cubed, right? This is not that. So this does not work. So if you see a plus or minus or any kind of term that separates your pieces under a power, you cannot distribute that power. It only works if it's multiplication, okay? All right, so stop this. You want to complete classroom problems 7 through 18. Okay, let's simplify some expressions. So here I have x cubed times y to the negative 3. In these kind of things, I always take all my negative exponents. So the first thing I look at are negative exponents, and I change those to positive exponents. Well, they're reciprocals, so y to the negative 3 is the same thing as 1 over y cubed. So then I just multiply x cubed to 1 over y cubed. That's just x cubed over y cubed, and we're good, okay? I didn't show it here, but if I wanted to, since they're both cubes, I could do another equals and x divided by y, and then parentheses, so the whole thing cubed if I wanted to. All right, let's say this. So here I have all multiplication and division, right? There are no plus signs or minus signs, so I know this negative power, this negative 3, applies to everything, right? I can do that little trick like we learned on the previous slides. So it's all multiplication, this negative 3 applies to everything. Well, I'm going to do the negative first. So remember, a negative is a reciprocal. So instead of 2x over y squared, I'll make it a y squared over 2x. And notice the power is now positive, right? Because that's what a negative power does. It's the reciprocal. Well, again, now that it's all multiplication, I can just distribute my 3 and my power. So it's y squared cubed and 2x cubed. So power raised to power, I multiply. So that would be a y to the 6. And then again, I have multiplication, so I can distribute this power to each piece. So I'll get a 2 cubed is 8, and then a x to the first times cubed is just x cubed. Okay? All right. And so you want to stop the video and complete classroom problems 19 through 22. All right, let's try some more complex, right? Some rational expressions here. So notice I have numbers, I have like variables, like bases, x, and then like bases, y. So I'm going to split them up here just to show you that I kind of group them together, and I do each piece. So I reduce 2 divided by 6, so 2 goes into 6 3 times, so this will be a 1/3. Here I have like bases in division. So I'll do the 5 minus 2. So I'll divide out these two x's from these 5. So I'll do 5 minus 2. And then notice on this one, the 3 is in the denominator. The largest power is in the denominator. So what's going to happen? This y will actually divide out one of these. So I'm going to actually take it 3 minus 1. I'm not going to do the numerator. So since the power was greatest in the numerator, I'll keep the x in the numerator and do 5 minus 2, which will make it a positive power. And then since the power is greatest in the numerator, the denominator for y, I'll do 3 minus the top, which will keep it positive in the denominator. All right. So if I want to make sure I always end up with positive powers, I just take the largest power and subtract off the smallest one and keep the base where the largest power was. All right, that's my deal. Then you can see my 1/3, my constants came out, so then I'm good. All right. Okay, let's try this. So I'm not going to split it up like this. I'm just going to write it all together. So the first thing is I have 15 and 6. So I want to factor those out. I didn't show the 6 here as 2 times 3, but I'm going to do the factors here. So 15 is 3 times 5, and 6 is 2 times 3. And now I have a negative exponent in the denominator, so I'm going to move that to the numerator. And I have a negative exponent in the numerator, which I'll move it down to the denominator. All right, so 2 things happened here. I factored out my 15 and my 6. And then anything that had a negative exponent, I moved it from either the denominator, if it was there, to the numerator. So that's why it's x cubed for positive. And then it was in the numerator for a negative exponent. Now it's in the denominator. So remember, negative exponents are reciprocals. So now the 3's divide out, so I'm with a 5 and a 2. And I have like bases, so I add exponents. So this should be x to the 5th and y squared. All right, so that would be that simplified. Okay, so you want to stop this and complete classwork problems 23 through 29. It's actually the end of the video, so that's it.